So following on from the previous video, we were trying to determine if this series will converge or if it will diverge, and we needed to use a ratio test. So the ratio test requires us to get the next term divided by the current term, and it was blah blah blah, and then we got to this stage here, and this is an indeterminate form. So we can't just simply say it's 1 to the power of infinity equals. We can't do this. This would be wrong because you've got a bubble. The bubble here gets, well, it wants to get to 1. This one here wants to get bigger and bigger and bigger. It's an indeterminate form. You can't conclude anything. So we need to evaluate this. So to evaluate this, let's just call to evaluate this. Let's just say this thing here. Let's just say this thing here equals y, and it is a y that we're trying to determine. We are trying to find out the limit of this. Let's just say the limit of this is y, and then later on we are trying to seek y. Okay, so we are really trying to find this. If this is greater than 1, we know it's going to diverge. If it's less than 1, we know it's going to converge. But we are trying to find out this. Let's just call this thing here y. Let's just call it y, and then it is a y that we're seeking. So we are trying to seek y. So here we've got n over n plus 1 to the power of n. So we are trying to work out y here. So from here, take the natural log of both sides. So take the natural log of this side. This will then come down here. That will then give us this thing, multiplying with this thing. So from here, take the natural log of both sides. That will then give us this. So here you've got one block multiplying another block. If you look at this block here, remember, as n heads towards infinity, n over n plus 1 will be 1. So the natural log graph looks like this. Natural log of 1 is 0. So this thing here wants to be 0. This thing here wants to be, as n heads to infinity, wants to be infinity. So here you've got 0 times infinity is an indeterminate form. So we would use L'Hopital's rule. But before we can do that, this is a trick that we have always used in the past. When you have one thing, so this thing wants to head towards 0, this thing wants to head towards infinity. 0 times infinity. The trick that we have always used in the past is to rewrite this as a quotient. Rewrite it as a fraction. So rewrite this thing here as one thing divided by 1 over n. So this is a trick that we've always used in the past. So reimagine this thing here as one thing divided by 1 over. So this is exactly the same as this, just written differently. Okay, and it's a trick that we've always used in the past. So now looking at this, as n heads towards infinity, this thing here wants to be 1. So natural log of 1 is 0. So this whole thing here wants to be 0. This thing here, as n tends to infinity, it wants to be 0. So you've got 0 over 0. It's an indeterminate form, so you can use L'Hopital's rule. So differentiate this, that will then give you this. Differentiate this, that will then give you this. So when you come to differentiate this, if I were to give you log of a bubble, to differentiate it, you would say 1 over the bubble times the derivative of the bubble itself. So 1 over this thing here is actually the reciprocal. So that will then give you this, and then times the derivative of the bubble itself. Well, times the derivative of the bubble itself is you using the quotient rule. So remember, the quotient rule would be v squared, and then v stays, well, use whichever method you want. So it would be something like this, and then v prime times u. Well, do whatever you want. Differentiate this. That will then give you this. Okay, yeah. If you can't follow this, press pause and think about it. Differentiate this. That will then give you this. Differentiate this. That will then give you this. So now it's just a matter of tidying up. So here you've got n plus 1 minus n. So these two will cancel out, leaving you with 1. And then this thing stays the same, stays the same, stays the same, and then this thing here stays the same. So from here, that will then take us to here. And then now tidy this up. So here you've got a bubble here, and the exact same bubble but squared. so they cancel each other out. So that will then give us this, and then this stays intact, and then let me think, and then you've got one fraction divided by another. That's the same as you multiplying by the reciprocal. So that gives you this. So now it's top times top, bottom times bottom. So hang on. So you've got n squared here. This will cancel out with n here, giving you negative this thing here. So now as n heads towards infinity, nothing breaks down. You've got well, this is going to be 1, so you've got negative 1. So as n heads towards infinity, the limit of this will be 1. But remember, right from the start, we took the natural log of both sides. So it was natural log of y equals this thing here. Natural log of y equals negative 1. But it is a y that we're seeking. So we would exponentiate both sides. So so from here, e equally to both sides. So e here, and then e here. Well, these two in a way cancel each other out, leaving you with y. So these two will cancel each other out, leaving you with y. E to the power of negative 1, that's the same as 1 over a positive here. So now y equals this thing here. So remember, y equals this thing here. So let me go back right from the start. Right from the start, hang on. Right from the start, we said that this thing here equals this thing here. But then I said, let y be this thing here. Let y be this thing here. And then we can take the natural log of y to both sides. Take the natural log here. This will then come down here. And then, well, y here, we said, let y. We said, let y be this thing here. Well, now we've just worked out y. Y is this thing here. Y is this thing here. And this thing here is this thing here. The reason why I introduced this y here is because we wanted to take the natural log of both sides. So this n can come down here. Well, we've now worked out y. We now have a value for y. We now have the value for this. Y is this, remember? And then that's this thing here. So hang on, going back down here. We now have we've now just worked out y. So let me scroll back down here. We've now worked out y. So bear with me. So we've now worked out y. So we've now worked out y. Y is this thing here. So the limit of this is actually 1 over e. So yeah. So y. Well, this thing here is 1 over e. Now 1 over e. Remember, e is roughly 2.7. So this thing here is going to be less than 1. Well, if this thing here is less than 1, if this thing here is less than 1, then we can conclude that the original series itself will converge. So yeah, so the whole series itself here will actually converge, because when we took the limit of the next term divided by the current term, it happens to be less than 1. Because it's less than 1, we can conclude that the original series will converge. So this thing here will converge. Okay.